Welcome back, everyone. Next thing we are going to talk about is kind of some technologies for actually viewing things in space. First, we'll start with telescopes. So we don't know exactly who invented the first one, but we do know that it was in 17th century in the Netherlands. And then Galileo got word of that, and he was like, this sounds really cool, except you guys didn't do it right. I'm going to build a better one. And so he did. And then he was like, you know what? I didn't do it right either. I'm going to build another one, and another one, and another one. And so that's why the telescope is typically attributed to Galileo, but he was not actually the original inventor. So there are two main types of telescopes, refracting and reflecting, named for what they do. Let's look at, this would be our refracting telescope. So light is going to come in from this end. Let's say that we had our star we were looking at. Say it was the sun. Don't look directly at the sun. But let's say you were. This is your star. It's sending light in here. When it hits that lens is not perfectly flat. It is curved so that it bends the light. Which means if the light has been bent, that is what the word refracting means. So it crosses over like that. And the problem is that we now have light that is not coming in nice and straight. So if we were to just put our eyeball here, it would not look like anything in particular to us. So what we do is we put another lens there, and that is going to straighten the light back out, and now we can see it. Except here's the thing. We started with, let's say, this picture right here. So I'll make the top of this arrow blue, and I'll make the bottom of it red. So the blue part has come through here, and then down like this, and then like that. So we have the blue part there, and we have the red part. So this has actually been flipped upside down. And this happens every single time you use a refracting telescope. It flips your image upside down. So now let's compare that refracting telescope we just looked at to a reflecting telescope. We are still going to have light coming in from whatever we're trying to see, but this is not a lens. So it's not going to bend the light. What it's going to do, that's a mirror, going to reflect the light. It's going to hit another mirror, which is going to reflect it again, because you can see when we reflected it, it wasn't straight. So we wouldn't be able to look at it properly. This second mirror is going to send it, again, still not straight, but we've redirected it out towards the eyepiece. And then on the end, we have a lens, which is going to bend these two crooked lines to be straight so that we can look at it and see a regular picture. So, Galileo wanted to keep making his stuff bigger and better. Turns out that we want to do the exact same thing. So if you look at this picture right here, that is essentially one really, really big reflector. Each one of these things would be a mirror, and you put them all together, and it essentially works to be one really big reflecting surface. Kind of on the same idea here, like this, is basically just a really, really big telescope. Same with this one over here. And the reason why we want them to be bigger and bigger and bigger is because you can see further and further and further at higher and higher quality of images. So you can get more contrast to actually see what's going on. You can have less distortion. Bigger is better in the telescope world. Okay, resolution would be the fancy word for being able to see better. If you combine a bunch of them together, it's called interferometry, which basically says, okay, I have this one right here and I have this one right here. The way that it works is you can kind of try to put, like, let's say there was a picture of something up here. You can piece it together based on, okay, what does this one see? What does this one see? What does this one see? And you can kind of get like a 3D representation of it that way, because you're getting different angles from different places. We talked about the Hubble Space Telescope a little bit in the last lesson. And the reason why this one was so great is because you don't have that distortion from the atmosphere, because it is physically above the atmosphere. So like we talked about the mountains for the last one, those are a good place because there's not going to be much light pollution. It's pretty undisturbed. You're still fairly high up. Like the atmosphere is starting to thin out by there, but it's not as good as actually being out in space.